Question number 1. Calculate the value of x plus y plus 2z minus 12 when x equals to 5, y equals to 8, and z equals to 9. Okay, so to solve this one, we are going to substitute the given values of x, y, and z into our expression. Then we are going to have 5 plus 8 plus 2 times 9 minus 12, of which after solving the values, we are having 19. And this is going to be our answer. Question number 2. The number of students who sat for primary school leaving examination in 2013 was 844,938. We are supposed to express this number in a standard notation. Okay, so for this one, we have to remember that the format for standard notation stands for A times 10 power n, where A should be greater or equal to 1, and it should be less or equal to 9, and n is an integer. Okay, so now we can say that our given value should be reduced to 8.44938. Then we are going to introduce 10 power 5 since a decimal point has been introduced after a fifth digit from a place value of ones. Then our standard notation will be 8.44938 times 10 power 5. And that is going to be our answer. Question number 3. If A and B are complementary angles such that angle A is 18 degrees less than B, determine the angles. Okay, so for this one, we have to remember that complementary angles are two angles that make a sum of 90 degrees, which means A plus B must equal 90 degrees. Let us call this as equation number 1. From our question, we've been told that A is 18 less than B, which means that B equals to A plus 18. Let us now substitute B into our equation number 1. Then we are going to have A plus 18 equals to 90. Let us now add these variables. Then we are having 2A plus 18 equals to 90. Collecting these constant terms, we are going to have 2A equals to 90 minus 18. Solving this, we are having 2A equals to 72. Let us now divide by 2 both sides. Then we have A equals to 36 degrees. Okay, so now we have the value of A. Let us now substitute from this equation, which says B equals to A plus 18 in order to find the value of B. Then we are going to have B equals to 36 plus 18, of which, solving this, we are having 54 degrees. These are the values of angles required. Question number 4. Find the value of x in the equation 6 over x plus 1 equals to 12. Okay, so this is the algebraic problem. To find the value of x, we are going first to multiply by x plus 1 both sides. Then our expression is going to be 6 equals to 12 in brackets x plus 1. Okay, so now let us open these brackets. We are going to have 6 equals to 12x plus 12. Let us now collect the like terms. We are going to have 12x equals to 6 minus 12. Solving this, we are having 12x equals to negative 6. Let us now divide by 12 both sides. Then we are having x equals to negative 6 over 12. Simplifying this, we are having x equals to negative 1 over 2. And this is going to be our answer. Question number 5. Simplify the expression 9 in brackets a minus 3b plus 5 in brackets 4b plus a minus b. Okay, so for this one, first we are going to open the brackets by multiplying 9 and 5 in each term inside the brackets. Then we are going to have 9a minus 27b plus 20b plus 5a minus b. Okay, so next, let us collect the like terms. Then we are having 9a plus 5a minus 27b plus 20b minus b. Solving this, we are having 14a minus 8b. And this is going to be our answer. Question number 6. When 6 is subtracted from a certain number, the result is greater than 29. Write down an inequality that represents the possible values of this number. Okay, so you can see that this is an inequality problem. Okay, so let us now assume a mentioned certain number is x. So now we are going to have x minus 6 is greater than 29. The final inequality should be x minus 6 is greater than 29. And that should be our answer. Question number 7. Without using mathematical tables, evaluate in brackets 0.136 squared minus 0.148 squared over 0.136 plus 0.148. Okay, so for this one, using different of two square concepts, we can write our numerator as follows. In brackets, 0.136 plus 0.148 in brackets 0.136 minus 0.148. Then our fraction is going to be in brackets 0.136 plus 0.148 in brackets 0.136 minus 0.148 over 0.136 plus 0.148. Okay, so from here we can see that this one 0.136 plus 0.148 is common for both the numerator and the denominator. Then we can cancel them. Then our expression is going to be 0.136 minus 0.148, of which, solving this, we are having negative 0.012, and this is going to be our answer. Question number 8. The length of one side of a square is 3x plus 4 centimeters. If the side length of this square are doubled, find the equation for the perimeter after changing the length of the square. Okay, so for this one, we've been given the length of one side is 3x plus 4. So if doubled, we are going to have 2 in brackets 3x plus 4. Expanding this, we are having 6x plus 8. Okay, so we have to remember that a perimeter of a square is given by 4 times length. Now our new length is going to be 6x plus 8. Let us now substitute this into our formula. Then perimeter will be 4 times, in brackets, 6x plus 8. Okay, so now from here, let us open these brackets by multiplying each term inside the brackets by 4. Then we are going to have 24x plus 32. And this is a perimeter of a square requested. Question number 9. Find the value a over b given that 3 power a times 5 power b equals to 675. Okay, so we see that this is an exponential problem. Let us first express this 675 as the product of prime factors. Then we are having 3 power a times 5 power b equals to 3 times 3 times 3 times 5 times 5. Let us now write these factors in an exponential form. Then we are having 3 power a times 5 power b equals to 3 power 3 times 5 power 2. Okay, we can see that since the bases are equal, then we can equate the exponents. Then we can say that a equals to 3 and b equals to 2. So the requested expression a over b is going to be 3 over 2. And this is going to be our answer. Question number 10. The football ground at Marisa Secondary School is 12.5 times as long as the length of the basketball ground. If the football ground is 100 meters long, find the length of the basketball ground. Okay, so for this one, first let us assume y is the length of a basketball ground. We've been told that 12.5 times y equals to 100. Let us now express 12.5 as improper fraction. Then our equation is going to be 25 over 2y equals to 100. Let us now multiply 25 over 2 both sides. Then our equation is going to be y equals to 100 times 2 over 25. This becomes 200 over 25. Simplifying this, we are having y equals to 8. Therefore, the length of a basketball ground is 8 meters. Question number 11. Represent the solution set of the inequality 3x plus 4 is greater or equal to 25 on a number line. Okay, so first, let us find the solution for this inequality. We have 3x plus 4 is greater or equal to 25. Let us now collect the constant terms. Then our inequality is going to be 3x is greater or equal to 25 minus 4. This becomes 3x is greater or equal to 21. Okay, so now let us divide by 3 both sides. Then our inequality is going to be x is greater or equal to 21 over 3. Simplifying this, we are having x is greater or equal to 7. Okay, so next, to show this in a number line, we are going to start by drawing a straight line. Then assigning the integers 5, 6, 7, 8, 9, 10, 11. Okay, so next we mark the shaded circle on 7 and draw the line from this point. And this is our number line requested. Question number 12. In a certain animal farm, 10% of the animals are horses, 1/4 are goats, 0.15 are sheep, and 1/2 are cattle. Arrange these numbers in ascending order. Okay, so for this one, you have to note that ascending order is arrangement of the numbers from smallest to the highest. So to determine which is a smaller and which is larger number, we are going first to convert them into decimals. Okay, so we start with this one, 10%. Converting this into decimals, we are taking 10 over 100, of which this becomes 0.1. Our next one is this one, 1/4. So to convert this, we are going to take 1/4 times 100. This becomes 100/4. In decimal form, this becomes 0.25. And also, we've been given 0.15. So this remains as it is. Our last number is 1/2. So this becomes 0.5. Okay, so now from these decimals, we can see that arranging them in ascending order, we are going to start with this one, 10%. The next one is going to be 0.15. The next one is 1/4. And our last one is 1/2. And that is going to be our answer. Question number 13. Write 750 grams as a fraction of 5 kilograms. Okay, so this is the dimensions problem. First, we are going to convert 5 kilograms by multiplying it by 1000 into grams. So we are saying 5 kilograms equals to 5,000 grams. Okay, so now 750 grams as a fraction of 5 kilograms is going to be 750 over 5,000. Okay, so next, to simplify this, we are going to divide each term by 250. This becomes 3/20. And this is our answer. Question number 14. If John is X years old and Mary is 3 years older than John, write down an equation for the sum of their ages. Okay, so for this one, from the given information, Mary is 3 years older than John, meaning Mary's age is X plus 3. Sum of their ages is going to be X plus 3. Collecting the like terms, then we are having 2x plus 3. And this is going to be our answer. Question number 15. Determine the value of x that satisfy the equation x minus y squared over x plus 2 equals to 7, given that y equals to 2. Okay, so for this one, first, let us substitute the value of y which has been given from our question. then our expression is going to be x minus 2 power 2 over x plus 2 equals to 7. Okay, so next, let us now multiply by x plus 2 both sides. Then our equation is going to be x minus 4 equals to 7 in brackets x plus 2. Okay, so now let us open the brackets by multiplying this 7 in each term inside the brackets. Then we are having x minus 4 equals to 7x plus 14. Okay, so next let us collect the like terms. Then we are having x minus 7x equals to 14 plus 4. Solving this, we are having negative 6x equals to 18. Okay, so now let us divide by negative 6 both sides. Then we are having x equals to 18 over negative 6, which becomes negative 3. And this is the value of x required. Question number 16. Write 4 log 2 minus 1 over 2 log 64 as a single logarithmic expression. Okay, so for this one, first we are going to apply the exponential law of logarithm. Then we are having log 2 power 4 minus log 64 power 1 over 2. Okay, so next let us express this 64 as exponent to base 2. Then we are going to have log 2 power 4 minus log in brackets 2 power 6 power 1 over 2. Okay, so next let us simplify this further. We are having log 2 power 4 minus log 2 power 3. Okay, so next let us apply the values of the powers. Then we are going to have log 16 minus log 8. Okay, so next we are going to apply the quotient law. Then we are going to have log 16 over 8, which becomes log 2. And this is going to be our answer. Question number 17. Find the product of the GCF and LCM of 4, 8, and 12. Okay, so for this one, first we are going to find the GCF and the LCM. So we are going to draw a table and then we are going to list the given factors. So here we have 4, here is 8, and here is 12. Then for this one, first we are going to ask ourselves what is the lowest number that can divide either of these numbers. Then our number is 2. So we are going to have 2 here. Then 4 divided by 2 is 2. 8 divided by 2 is 4. 12 divided by 2 is 6. Then next we can see that we can still use number 2 to divide our factors. So here we are going to have 1, here is 2, and here is 3. Then still we are going to use number 2. So here is 1, here is 1, but here is 3 because we cannot divide this one by 2. Then our next number is 3. So here is 1, here is 1, and here is 1. Okay, so next to find the GCF, we have to recall that GCF is obtained by taking the product of the factors that manage to divide each number in a row. We can see those numbers are 2, and 2. So GCF is going to be 2 times 2, which becomes 4. Okay, so next we are going to find the LCM by taking the product of all the factors. Then our LCM, we are going to take 2 times 2 times 2 times 3, of which after solving the values, we are having 24. Okay, so next, to find the product of GCF and LCM, we are going to take 4 times 24. After solving the values, we are having 96. And that is going to be our answer. Question number 18. If the straight line AB that is passing through the point A 2,6 and B t, 3 has a gradient of -1, find the value of t. Okay, so this one is the coordinate geometry problem. We have to remember the formula to find the slope. M is given by M equals to y2 minus y1 over x2 minus x1. Okay, so from the given information, M equals to -1, x1, y1 is this one 2,6, and x2, y2 is t, 3. Okay, so next let us substitute these values into our formula. Then we are having -1 equals to 3 minus 6 over t minus 2. Solving this, we are having -1 equals to -3 over t minus 2. Okay, so next let us multiply this t minus 2 both sides. Then we are having -1 in brackets t minus 2 equals to -3. Okay, so next let us open the brackets. We are having -t plus 2 equals to -3. Next, we are going to collect the constant terms. Then we are having -t equals to -3 minus 2. Solving this, we are having -t equals to -5. Let us now divide by -1 both sides. Then we are going to have t equals to 5. And this is going to be our answer. Question number 19. If a triangle has two equal sides of length x centimeters each, and the third side measures 6 centimeters more than the length of these congruent sides, write down an equation that represents the perimeter of this triangle. Okay, we have been told that the third side measures 6 more than the other two sides. This means that x plus 6 centimeters. Okay, so please note that to find the perimeter of a triangle, we are going to simply sum the length of all the sides. Then our perimeter is going to equal x plus x plus x plus 6. Solving this, we are having 3x plus 6. And this is going to be our answer. Question number 20. Kapona bought a computer for 250,000 and sold it after 1 year at a loss of 5%. Calculate the amount of the loss. Okay, so for this one, we are going to find the 5% of 250,000. Then we are going to take 250,000 times 5 over 100. Simplifying this, we are going to have 2500 times 5, of which after solving the values, we are going to have 12,500. And this is going to be the loss made. Question number 21. The area of a rectangular room is 1,125 centimeters squared. If its length is 5 times its width, find its perimeter. Okay, so for this one, first let us assume the width of a rectangular room W equals to Y. Then length of the room should be 5Y. Okay, so let us recall the formula to find an area of the rectangular is given by area equals to length times width. Okay, so next let us substitute the values we have. We are going to have 1,125 equals to Y times 5Y. Solving this, we are having 1,125 equals to 5Y squared. Okay, so next, let us divide by 5 both sides. Then we are having Y squared equals to 1,125 over 5. Solving this, we are having Y squared equals to 225. Okay, so now let us apply the root both sides. Then we are going to have Y equals to under root 225. This becomes Y equals to 15. Then our width becomes 15 centimeters and length equals to 5 times 15, which equals to 75 centimeters. Okay, so next, to calculate the perimeter, we are going to use the following formula, which says perimeter equals to 2 in brackets length plus width. Okay, so next let us substitute the values we have. Perimeter equals to 2 in brackets 75 plus 15. Solving the values inside the brackets, we are having 2 times 90. After solving the values, we are having 180 centimeters. And this is going to be our answer. Question number 22. Evaluate 1.34 times 5.804 over under root 0.4391 using logarithmic tables. Okay, so to solve this one, we are going to prepare a table as follows. So here we have number. Here we are going to write their standard form. And here we are going to have their logarithm. So our first number is this one, 1.34. To write this in a standard form, we are going to write this way, 1.34 times 10 power 0. And to get the value for its logarithm, we are just going to read log 1.34 in logarithm tables, of which this becomes 0.1271. Okay, so our next number in our expression is this one, 5.804. To write this in a standard form, we are going to say 5.804 times 10 power 0. So for this one, we are going to read the value of log 5.804 in logarithmic table, then the value is 0.7637. Okay, so we can see that now we have the two values for the numerator. We are going to use the additional law of logarithm. We are going to take this 0.1271 plus 0.7637. After summing the values, we are having 0.8908, and this is the value of our numerator. Okay, so our next number is under root 0.4391. To write this in a standard form, we are going to write as in brackets 4.391 times 10 power negative 1 power 1 over 2. Okay, so to get the values for their logarithm, we are going to read log 4.391, and we are going to use the additional row by adding with bar 1 from this one, 10 power negative 1. For this one, we are going to get bar 1.6426. Then we are going to apply the exponential law. Then we are going to have 1 over 2 in brackets bar 1.6426. Solving this, we are having bar 1.8213, and this is going to be the value for our denominator. Okay, so next, by using the quotient law, we are going to subtract the denominator from our numerator. Then after solving the values, we are going to have 1.0695. Okay, so next we are going to find the antilog of this value from the antilog table. The antilog of 1.0695 is 11.735. And this is going to be the value of our expression given. Question number 23. A ladder 15 meters long leans against a vertical wall such that the top of the ladder makes an angle of 63 degrees with the vertical wall. Find the height of the wall. Okay, so for this one, let us consider the following sketch of the problem. So we have the wall, and this one is going to be the ground. And then we have this one is a line connecting the wall and the ground. So here is 63 degrees, here is 15 meters, and this is our ladder. So let us call this side as Y. Okay, so next, to find the height of the wall, we are going to use the cosine trigonometric ratio, which says cos theta equals to adjacent side over hypotenuse side. Okay, so from our sketch, you can see that our adjacent side is Y and our hypotenuse side is 15. The given theta is 63 degrees. Okay, so next, let us substitute these values. Then our equation is going to be cos 63 equals to Y over 15. Okay, so now let us make Y as a subject. Then our equation is going to be Y equals to 15 times cos 63. Okay, so reading from the table, cos 63 equals to 0.4540. Okay, so let us now replace this one into our equation. Then we are going to have Y equals to 15 times 0.4540 6.40, of which solving this we get 6.81. Therefore, the height of a wall is 6.81 meters. Question number 24. In a class of 50 students, 16 like watching television, 41 like reading storybooks, and 7 do not like neither watching television nor reading storybooks. Find the number of students who like both watching television and reading storybooks using the formula. Okay, so this is the set problem. Let us consider the following formula, which says number of A union B equals to number of A plus number of B minus number of A intersection B. Okay, so from the given information, number of A union B will be the total number of students minus number of those students who do not like either watching television nor reading storybooks. So we have number of A union B equals to 50 minus 7, of which solving this we are having 43. Okay, so number of A should be those who like watching TV, which have been given as 16. And number of B should be those like reading storybooks, which are 41. So from there, we are supposed to find the number of A intersection B, which are those who like both watching TV and reading storybooks. Okay, so next, let us substitute these values into our general formula. Then we are going to have 43 equals to 16 plus 41 minus number of A intersection B. Okay, so next we are going to collect the like terms. Then we are having number of A intersection B equals to 16 plus 41 minus 43. Solving this, we are having 14. And this is going to be the number of students who like both watching TV and reading storybooks. Question number 25. In the figure below, side EF equals to FG and EH equals to HG. Show that triangles EFH and GFH are similar. Okay, so this is the similarity problem. Let us consider the following fact. We have been given this information from the question that side EF equals to side FG. And also, we've been told that side EH equals to HG. Okay, so now we can see that side HF is common. Okay, so from these three facts, we can conclude that triangle EFH is similar to triangle GFH by side-side-side theorem.